Okay, so we are starting with our first chapter, that is 3D printing. So this will be our first module. So let's begin. So the contents in this chapter will cover up all the contents, that is, will go with the introduction of 3D printing, the process of 3D printing, the classifications, advantages, the comparison between the additive and the conventional manufacturing. Conventional manufacturing is the manufacturing which has been continued for the past years before additive. The conventional manufacturing, it is also called as subtractive manufacturing. I will explain this in detail further. Then finally, we'll go with the applications of 3D printing. So let's begin. So we'll start with the definition of additive manufacturing, or also called as 3D printing, rapid prototyping. There are various names for this. So additive manufacturing means addition. So the term says additive, means addition of the layer. So here you can see we are adding layer by layer. So we have a nozzle. The nozzle has a temperature. So it melts the filament and it is adding layer by layer. So additive manufacturing is a layer by layer automated fabrication process. So this is automated. Once you give the command, it's completely works on it itself. So it's an automated fabrication process for making scaled three-dimensional physical objects directly from the 3D CAD data without using part-dependent tools. So it is a layer by layer fabrication. Why it is called as fabrication? Because it is growing layer by layer, fabrication. So it is constructing one above the other. So that's why it is called as fabrication, making a scaled three-dimensional physical object. So we are making this 3D object by using 3D CAD data. So we are using different types of CAD softwares. You can use any software you want, and you can convert that into HTML file and you can do the remaining process. So we'll go through that process step by step in our future slides. So hope the definition is clear. Next, we'll see the block diagram for 3D printing. So this will cover the entire process of the 3D printing. So starting from the block diagram, we'll go from left to right. So first step is three-dimensional model. Okay, so we have a three-dimensional object, any three-dimensional object which we have to construct, that is entity model is the final product. So any three-dimensional object which we want to manufacture or do the process, so first we have to create that. So creating this three-dimensional model, we use different softwares, CAD softwares. Then we have to import that three-dimensional CAD file into the slicer software. So you have a slicer software which slice the CAD, the three-dimensional CAD file into layers, and then it is processed. So this block diagram consists of these three different parts: pre-processing, prototyping, post-treatment, and the final model. So I'll explain each and every term step by step. The basic: first you have a three-dimensional CAD file. Then in the pre-processing, we have to actual printing. Before actual printing, what all things we have to do, that comes under pre-processing. So before processing. Prototyping is the actual layer by layer formation of the object. Then post treatment is after we ready the object, what all things we have to do later on treatment to make it perfect, and finally we get the model. So now I'll explain each block in detail. So we'll consider the first block, that is the three-dimensional model. So what you have to make the end product, first you have to know what you have to make the end product. So according to that, using different CAD softwares. So in market we have various CAD softwares like SolidWorks, Blender, Tinkercad. Many open source softwares are there. So using any software you can create or design the three-dimensional model. So I'll give some example here. So for example, this is the basic Tinkercad software which we are using. So here I am building the block, just a cube, just for reference. So I've considered a cube. You can use any text, you can design anything you want according to your requirement, you can do. Then you have to export. Okay, so click on export. And from export, you can see you have different types of formats. So for 3D printing, we require this STL format, that is .stl, which is also called as stereolithography. So this type of software has to be loaded into the slicer software. Then this is the another software, Blender. Here also you can make the design, you can sculpt, export. Here also you can see you are using .stl, that is stereolithography. Then save anywhere you want, rename, and you can click on here export STL. So your STL file will be downloaded. So this is the initial step, that is making the three-dimensional model. So there are n numbers of CAD softwares are there in the market. So STL, again I'll repeat, it is called as stereolithography. So it is the format which is supported for the later your pre-processing support or pre-processing techniques. This STL file is used. So now you have to create the cube. So you have created the 3D model. So you can create anything you want in this using different softwares. So if you want to construct a mechanical object, you have to use SolidWorks. If you want to design a jewelry, then there are different softwares like Rhino. Here, this is the Blender software which you are seeing. So here you can sculpt the models, make accurate 3D model of a person, and then you have to download into STL format. Using this STL format, we have to go into this which is called as pre-processing. So pre-processing, where you have to use this generated STL file format and you have to add into the slicer software. Now what is this slicer software exactly? So if I have any 3D object, so this is the 3D object. So right now I have designed this 3D object. Consider this 3D object I have designed in the 3D software or the CAD format, which you have seen a square block. Now, as you know, each block is made by layer addition. So you have learned the definition that the object is made by addition of layers. So 1, 2, 3, 4. So there are n number of layers added on one on top of each other. So this three-dimensional object, for knowing the 3D printer that how many layers it has to stack one above the another. So it has to use one more software that is called as a slicer software. So which slice the entire three-dimensional object, which can be uh, given the codes to the printer, so it can generate the layer by layer addition. So for that we are using there are different slicer softwares, freely available softwares in the market like Cura, Ultimate Cura. But as we are using the 3D printer from Creality, so we are using their own slicer software. So in the slicer software, we have to add supports. If this object is printed like this, then it doesn't require any supports. But if the object is printed like this, so against the gravity, if you are making the object, then it will require some supports. So you have to add supports, you have to model the slice. So I'll show you how it is done. So here we are using the Creality software, and this is the object which we have imported earlier, that is the cube. So we are opening this into the slicer software. So this is how it has been opened. So it was a big model, so we'll scale it down. So here are a few options, like this option is to move, this option is to scale. So I have scaled it down. Using the scroll button, you can zoom it. So you can again increase or decrease or scale the software. I'll make an entire video on this software only. We'll explain each and every term. So right now you can see the basics operations. Here you have, you can move, you can rotate using the clicks button. So here are the options. You have the different types of quality which you can print, the super fine, fine, recommended quality. We are using the recommended standard quality, that is the 0.2 millimeter layer thickness. The infill you can change accordingly you want. So here I am keeping 20% as the infill. Infill is nothing but the density to which the object will be filled. This object doesn't require any support, so we are keeping it no. Then when we model on the slice, So this is how it has done the slicing. So if you move this bar up and down, so this is the entire layer. You can check each and every layer how it will be printed. So this is how it will be printed. So if I'm increasing this bar above, so this is all the layers. So there are around 145 layers which will be there. This is the topmost layer, how it will be printed. So this is the slicer software. Now your STL file using this software has sliced each and every layer. So now we have to download this file. So now our STL file is converted into one more file that is called as G codes. So .g code. So our entire file now is converted into .g codes. So using the CAD software, we are getting the STL format, and using the STL format, now we are downloading this into another format that is called as G codes. So our 3D printer only recognizes this G code files. You can't upload the STL file into our 3D printer. You have to convert the STL files into the G codes. So this G codes now will be uploaded into our 3D software. Now before moving forward, I'll just explain you in short again what you just uh, you heard in the previous slides. So this is the file which we have got in our Tinkercad file or the 3D CAD file, which we have opened this into our slicer software. So this is the slicer software, Creality slicer software, which comes with the 3D printer. So the various options here you can see, I'll explain this in detail when I explain this slicer software. So this first option is nothing but we can move this object. Second option, we can scale up, scale down this object. Here you can rotate. There are few options. We can mirror image, we can add supports and everything. Here you have the option. This is the nozzle diameter, which comes from like 0.08 millimeters till 1. So this is the finest quality which you can print, and it will go from 0.08 to 1 millimeter thickness of the layer height. So each layer of our object will be that much height of. Then this is the infill percentage. This is the 100%. This block will be entirely filled inside with the filament. And according to that, this is 20%. 20% is the recommended. 10% you can do it accordingly. Then you have gradual infill. Gradual infill will gradually infill. Bottom part, it will be the lowest. Then it will keep on increasing as we move on the upper side. You have more such options. I'll explain this in detail later when I explain this Creality software. Now basic things I'll explain how it is going. Like if I click on slice now, we are not putting the gradual infill, 20% infill, we are adding support. But this doesn't require any support as this block is a cube, so it doesn't require any support. It will require support if it is at an angle. So now if I click on slice, it is showing me 46 minutes, and this is the 7 grams of filament it is being using, approximately around 2.32 meters of entire filament. Here if you hover on this, you can see more such options like infill, how much it is using, inner walls, outer walls, everything in detail it gives. So if I click on preview, so now it will show me layer, around 126 layers are there, and each layer will be like this. So this is the infill. So now this infill is 20%. If I increase the infill like around like 80%, and again I have to do the slicing. Now the time required also increases, the grams, everything increases because the infill is much more. So now you can see the boxes, the infill density is increased. It is around 80%. So likewise, you can increase as you want. If you click on gradual increase, do the slicing. So here you can see at the bottom, it is the lowest infill. So this is the infill. You can see it is the lowest. And as it is approaching upward, the infill density is increasing. So top, it is the highest thing. So it is around 6 grams of filament it is using, 41 minutes. So you can change the settings accordingly. Now as per your settings, whatever settings you have done, so supports, I'll explain about supports as it is there in the block diagram. So if my object is rotating like this, if my object is like this, now it will require supports because it is against the gravity, so it will require supports. So now I have to click here on supports, then slice. After slicing, go to preview. So now you can see these are all the supports which are there required for this. So supports also. So as you can see, the time is also increased, and this is the infill and all the supports required. So moving back to the basic thing. So now this file has been sliced. Now you have to save this file. So you have made this three-dimensional object into the CAD file, and we have got that .htl file. Now you have to we uploaded that .htl file into this slicer software. Now through this slicer software, we will get one more file, that is .g code. So here you can see .g code. I'll name this as just box, and you can see the file is G code. So save. So now this G code, this box G code file, this I have to get into my memory card, and that memory card will go into the 3D file. So this you can again view the G code. G codes are basically what? I'll open this with Notepad. You can open this with Notepad. You can't open this with Slicer software, as Slicer software only support .htl file. You have to open this with Notepad. Now here you can see you have the entire code. So this is the code. It is a huge code. So, but this basically code is nothing but the coordinates. These are the coordinate X, Y, and Z coordinates are there. So it gives the coordinate or tells the printer where you have to start the printing. This is basically the locations of the printing. So you can view the G codes. The initial and the final G codes are there. The entire set of codes, you have to upload this into our memory card, and the further process I'll explain. So now as we have got the G code into our memory card, so now we have to go to this next step, that is prototyping. So that memory card you have to insert it into our 3D printer. Then all the information of the G code will be fetched by the 3D printer, and layer by layer processing and bonding of that 3D printer, the object will be happening. So in my next slide, I'll explain with this with a whole video. So this is our 3D printer. So now as we have uploaded our G code file to this memory card, we'll insert this memory card into the soft. Now first we have to do the bed leveling and everything. I've done it already. So this is the PLA filament. The PLA filament nozzle temperature, it melts around 200 degrees Celsius. So we have kept the nozzle temperature at around 205 degrees Celsius, and this bed temperature is around 55 degree. So here you can see, so this is the nozzle. Here you have the nozzle. So the filament is coming right away. So the settings, to go to print, so the box, so I have replaced it with a number. I am printing another file, but then you have to check whether the temperature is accurate, then click on play. So here before starting it will do some homing. So at the center it will go and it will do some homing position. It will check the center. The time also comes here before starting. So this is the initial line which it always prints. So this is the check line. Any filament which extra filament, it comes down on this line, then it starts printing our actual object. So here again we have another example where the layer by layer process you can see. So see how from the nozzle the filament is pouring down layer by layer and it is happening. So this is the layer by layer process. So this is another object which we are printing. Again, so these are some more videos where you can see from the nozzle how the layer is, the filament is melting down and it is getting layer by layer process. So this is the object. One more beauty about the 3D printer is that this object is made in a single piece. So generally in traditional manufacturing, if you see this object, two parts has to be made, but this object is made in a single piece. We have to just give a little force, and this object is basically a filament holder which we are making for our project. We are making a dehydration box and this is the filament holder. So as you can see, this is made in a single object. So that is one more advantage of 3D printing. So as I explained, in traditional manufacturing, if you are making this object, this part has to be made separately, this part has to be made separately, then we have to join with a rod or something and the movement will happen. But as you have seen, this has been 3D printed in one single shot, no two parts. It is printed in a one line code. So finally, next block part is the post treatment. Post treatment is nothing but after making the object, we have to do some polishing. So after making this object, we have to do some polishing. We have to do coloring. Okay, so coloring also comes under post processing. Then if there are any grooves, polishing, painting, and many more things comes under post processing depending upon the type of the object we are printing, the filament which we are using. So depending upon that, the post processing increases. So we have to remove the supports. So as I mentioned earlier, the supports, if you are printing this object at an angle, so we'll require some supports. We have to remove those supports, clean the surface, and that is also called as a curing process. So here are few objects. So here you can see these are all the supports. Then we have to remove the supports. We have to do the sanding or the polishing, and we have to do the painting. So this all comes under post processing. So final, this is our entire block diagram. Hope so it is clear. And finally, the entity model, you get the object which you can use it for the purpose. So this is the entire block diagram. Hope it is clear to all. So moving. So next we are studying about the classification of 3D printing. So 3D printing or additive manufacturing is classified broadly into material extrusion. Material extrusion is nothing but the printer which we have seen. We are using PLA or the ABS material. The filament comes from the top, then it melts down with the nozzle and then layer by layer processing is done. That is the material extrusion. So that is the widely used 3D printer. Then next you have VAT photopolymerization. So here VAT means nothing but the bucket of the material. So here we are using the liquid material, that is the resin material. And photopolymerization, photo, whenever the word photo comes, you should understand that is nothing but we have some UV light or the X-ray light, something related to light. Okay, so you have a liquid and you have light. Here you have the solid material which melts and layer by layer process is done. This is also layer by layer processing, but you are using light and you are using liquid resin or the liquid material we are using. Next, you have sheet lamination. So metal sheets can be cut down and it can be made an object. Then you have powder bed fusion. So powder bed fusion, here the metals can be or the engines, metals can be manufactured using this 3D printers. So you have a powder material, and if any liquid is poured or any specific liquid is poured, then it gets solidified. Okay, so all this process I'll explain in my further chapters in detail. So for powder bed fusion, basically understand it's like cement. If you consider a cement, and if you put water, it gets solidified. So likewise, you have a powder material, metal material, and if the liquid is added, specific liquid is added, it gets solidified, and you can design an entire titanium or metal, any metal you can design using this powder bed fusion. Further classification in material extrusion, you have fused base fabrication and you have liquid deposition modeling. In white photopolymerization, you have stereolithography. Sheet lamination, you have laminated object manufacturing. Composite base additive manufacturing, and finally in powder base fusion, you have selective laser sintering. So I'll explain each of those in detail in my further chapters. Now moving forward, we'll study about the comparison between the additive manufacturing versus the traditional manufacturing. So traditional manufacturing is nothing but the manufacturing done with the CNC machines. So it is also called as subtractive manufacturing. So additive manufacturing, as you know, layer by layer process, it is adding. Subtractive manufacturing means you have a block and then you are cutting down the material. That is called as subtractive manufacturing. So CNC machine, it is like that. So if you want to design this model, if you want to print this logo, then you have a cylinder which is smooth. Then through the laser cutter or any cutter, you will engrave that. So the material will come out. So that is called as subtractive. You are subtracting the material. This is adding of material. So the biggest advantage is that in this it is zero material loss. And when you do subtractive manufacturing, obviously you get loss of materials. So first parameter is the working principle. So in additive manufacturing, you are using building object layer by layer. So layer by layer object. And in traditional manufacturing, you are creating the object by cutting away the solid block of material. So this is the diagram. This is the subtractive manufacturing. You have a tool and you are cutting down the object and you are giving the shape. And this is the final product. In additive manufacturing, you have the nozzle. So layer by layer deposition is going on and you get the same product. So here there is a loss of material. Here there is zero loss of material. Okay, so next parameter, you have cost. So cost wise, obviously the production of elements at the cost of material. So whatever the cost of the material is there, you are using, if you are using carbon fiber, the material cost will be more. If you are using minimal cost materials, then it will be less. So depending upon which material you are using, the cost will increase. It can be more cost effective in traditional manufacturing if you are producing in large quantities. So if there is a large batch of products you are using, then the cost will be much lower. Then time, obviously in additive manufacturing, it will usually take several hours. In traditional manufacturing, if the object is more complex, it will take more time, more labor cost will be required. Then consumption of resources in additive manufacturing, very minimal consumption of resources. Whatever resources you are required, only that much is needed. In traditional manufacturing, it is high consumption of materials is or resources is there. Product possibility to produce product with complex geometry. So any complex geometry can be molded easily. So depending upon what we want, you can easily recreate in the CAD software and you can design. Then limited production in traditional manufacturing, limited production, the complexity will be quite less. Complex is more than it is limited. So next parameters are the post-processing and quality of the material. So in post-processing, it is not always necessary you require in 3D printing. If this object don't want to color anything, you can directly use this object. So it is not necessary. In traditional manufacturing, the final processing is always required. Any dust particles are there, you have to remove. So in most of the cases, it is there. Quality of the material, properties similar to steel. So any type of material you are using, so according to that, it will be there. So you can see the quality, it is quite smooth. So it is too good material. In traditional manufacturing, it is load bearing. The quality of the material is according to the what the bearing or the costing is there. So next two parameters are the material losses. So in additive manufacturing, it is low, very low, or it can be none. Only the supports will be there. If there are there, then there will be some material loss. In traditional manufacturing, obviously it is a subtractive type of manufacturing. So there are high losses. Manpower, low in additive manufacturing, will require a CAD manufacturer, one slicer, 3D printer operator, and that's it done. In traditional manufacturing, in each and every stages you require manpower, skilled labor you require. In additive manufacturing also you require skilled persons, but with high qualification you require. But manpower is quite low than traditional manufacturing. Next, we'll define what do you mean by material extrusion. So extrusion is nothing but from the nozzle, the material, how it comes. That is called as extrusion. And material is coming, so it is called as material extrusion. So material extrusion is an additive manufacturing methodology where the spool of material, so this is nothing but the spool of material, is pushed through a heated nozzle. So you have a heated nozzle over here in a continuous stream and selectively deposited layer by layer to build the 3D object. So here you can see the material is spooled from the material is injected from this nozzle, and layer by layer it is adding. Okay, so this is how this is the definition of material extrusion. Next, we will learn about the different post-processing techniques. So after making the object, what we have to do, what to make it look much better. So we have some post-processing techniques. First is the support removal. Obviously, if the object is printed, you have to remove the supports. Then sanding making it smooth. Vapor smoothing, this is another technique. Priming and painting, you have to paint the object if required. Polishing, electroplating to make it neutral. Then gluing and welding, if you want to, if you have made two parts, joining of them, gluing, welding. And hydrophobic, treating it with water, as it is like, if you want to make it susceptible to moisture, you have to do some hydrographic. So now the final topic here we'll study about the applications of 3D printing. So there are n numbers of applications of 3D printing, starting from the education purpose, prototyping, manufacturing, making cars, designing anything, huge applications, medicine industry. Then construction, the entire building is now constructed using 3D printing technology. Art and jewelry is designed using 3D printing. Aerospace, defense, or using prosthetic human organs, heart, lungs are designed and manufactured using 3D printing technology. Then again, biomedical implants are made. Pharmaceutical companies are also using 3D printing technology. So the list is very huge. There are few of the applications I have mentioned here. You can Google it. You can find n number of applications of 3D printing.